All right, well, as you can probably imagine, I did not plan to be out today. I got home last night, was really not feeling good, and so I'm going to call in for a sick day. So what we have here is actually a review of what we've already talked about, but it takes us a step further, and I want to walk you through a couple of examples here. I'll try to do this as quickly as possible. If you don't understand something, go back and watch it again. But I want to review real quickly here. What does this mean versus this? Okay. So we have greater than or equal to. When you graph these on the coordinate plane, remember that the greater than always shades above and has a dotted line. So if I go ahead and do something like this, dotted, okay, supposed to be dotted, all right. The shading above would be on this side over here. Okay, that's above that line right there. All right. If I have a horizontal line that's dotted, okay, the shading would be above again over there. If I have a line like this, oh, that should be dotted, sorry, ignore that. Dotted, okay. The above should be to this side, okay. So wherever the positive values are, wherever the above is going to be, that's what you want to go ahead and figure out. So if I have a vertical line, think to yourself, where would the greater than be? It would be over here, greater than, okay? So I hope that makes sense. If it's greater than or equal to, obviously you're going to make a solid line. If it's greater than, we're going to shade above, okay? If I have a vertical line, okay, shading above, so all the positive values would be to this side, okay? And if I have a line that goes like this, the above would be here, okay? And if I have a line that is a positively sloped line, my greater than would be there, okay? So that was just a review of the greater than or equal to. Obviously the less than or equal to, those will all be the same but in reverse, okay? So I think that's enough reviewing from what we've done before. Let's take a look at some of these examples here. So in number one, we want to figure out where these two equations come together, okay? So what answers would not only be a part of the one inequality, but would also be part of the other inequality? So if I go ahead and graph this, okay, y is less than or equal to negative 3, okay? Well, I'm going to go down here to the y value of negative 3, place a point, okay? And then because it's a y is less than or equal to, it's a solid line right here, okay? Now the shading on this, because it's less than, is going to be down below. So all the shading down here, okay, that would be less than, all right? Now, if I go to the other equation, x is greater than 1, if I go to the x value of 1, place a point, okay, this one's going to be a dotted line, okay, and x is greater than that, so everything on this side. So what's the answer to this type of problem when we have the two inequalities coming together? Well, we want to be able to see, let's see here, we want to be able to see where the answers overlap. So this line right here, because it's solid, would overlap. This line would not overlap, but everything inside of that line, okay, all of this, any number, any ordered pair, if you were to pick 2, negative 4, that point right there, that point would satisfy both of these. If I go over 2, is that greater than negative 1? Yes. If I go over negative 4, is that less than or equal to negative 3? Yes. Okay. So we're looking for all of the possibilities that would satisfy both inequalities. Okay. So if we look at the next one, let's go ahead and change colors here. Y is greater than 2. Well, if I go up to 2 on the y-axis, okay, greater than would be a dotted line. Dotted line, there you go. Okay. All right, greater than would be up in here. Okay. X is less than negative 2. So if I go to negative 2 on the x-axis, let's change colors here so we can see this a little bit better. Okay. Dotted line again. And this time we're going less than. So I'm going to shade in the less than here. So what's the answer? The answer in this case is everything inside this box here, but not including either line because they're both dotted. Okay? So, I'm going to do number 3 and then number 5 with you, and then I'll let you guys get started on some of the other ones. I want to do one down at the bottom, and I want to look at the first one on the back as well. So it's not going to take very long to look this over. When we look at number 3, this equation is in y equals mx plus b form. Okay? Here's your y-intercept. Okay? And this is your slope. So as I put this down here, the slope is 1, y-intercept is 3. 1, 2, 3, put a point there, and the slope is 1. Now it's dotted, so I'll just go ahead and do this. Okay, I'm about started making a solid line there. It's dotted. Okay. Now if we're greater than that, above that inequality would be right here. All right. Now, if we're less than or equal to -1, let me change colors again. Less than or equal to -1 for the y value. There is no slope. This is the y-intercept, -1. Okay. And we want a solid line here. So this is y less than or equal to -1. Now, less than would be everything to the bottom of this, so down in here. Okay. So where does our answer lie? Well, like the last two, it's where they intersect. This line, because it's solid, not this one, because it's everything inside there, as it continues out this way as well. Okay? All right, now, you're probably getting the hang of this. I want to take a look at number 5 now. Okay, number 5 is not in graphable form yet. All right? So what we're going to do is we are going to solve for y so that we can get it in graphable form. So as I look at this equation, if I go ahead and subtract x from both sides, you end up with this. Y is less than or equal to -x, because I subtracted it, -1. Okay? For the other equation, if we do the same thing, if we subtract x from both sides, we end up getting, excuse me, my nose is running. We end up getting y is greater than or equal to -x plus 3. Okay? Now, the one thing I do want to encourage you to do is make sure that the only time you flip the inequality, again, remember, is when you divide or multiply by a negative. Okay? So if I go ahead and do my y-intercept, -1, and I have a -1 slope, that line right there, okay, solid line because it's less than or equal to, okay? So less than would be below, all right? Now, to go ahead and do the other one, y is greater than or equal to -x plus 3, let's go up 3, and we have a -x, negative slope. -1 slope. Again, it's a solid line because it's or equal to. And we want greater than or equal to. All right? So from there, what did I do here? Plus 3. Oh, I see what I did. Sorry, guys. My sickness has gotten to my head. Let me backtrack here. I apologize. I'm supposed to do a negative slope. Okay? So as a result, let's see here. -1. Good. So this should be okay. So y is greater than or equal to -x plus 3. All right? So if I go ahead and do this right here, here's my question for you. Do either of those inequalities cross over? Do they share any points together? And the answer is no. And if they don't share any points, what is our answer? It's going to be no solution. Okay? No solution. Okay, so I hope that makes sense. It's outside those limits there. Less than the lower one, greater than the higher one, and they're never going to cross. Okay, they are parallel to each other. All right, now, the next one I'd like to look at with you guys is number 10. So let's go down and look at number 10. Let's see here. There. All right, number 10. We actually want to come up with the two equations that would satisfy this shading right here. Okay? So what we want to look at would be this. You want to find your slope and your y-intercept of both equations. Okay? So as I look at this one right here, okay, it looks like my y-intercept is down 1, 2, 3. So my y-intercept is negative 3. Okay? Now my slope is up 1 over 1. Okay? Up 1 over 1. Okay? So that is a positive slope. So I get x, or plus 1. Now, it's shaded above. If you notice here, I'm going to change the color here. This is shaded up above when we're talking about this line. And it's also a solid line. So I'm going to go do greater than or equal to, and I'm going to do y. Y is greater than or equal to x. The slope is 1, remember, minus 3, the y-intercept. Okay? If I look at the other equation, I can tell it's a solid line and it's shaded below. So this is going to be less than or equal to. Okay? Now the y-intercept here, if I count this, is up 2. And it has a slope of up 1 over 1, just like the previous one. So you can go ahead and do this, or just x plus 2. Okay? So I hope that made sense. You can go ahead and try numbers 11 and 12. The sub will have the key if you want to make sure that you have the right answers. And you can go from there. All right, now I want to flip over to the back side. Okay. And I want to talk about this part right here. Okay. A little bit more challenging problem here, where we're trying to encapsulate more than one inequality. Okay. So to make sure that we've got this down, I want to make sure you understand this one and this one. Then we're going to talk extensively about that one because it will come into play down below. So as we look at this, if I go ahead and say plus 1, a negative slope, plus 1, a negative 1 slope. Okay. You notice here that all the lines are solid. So we've got less than or equal to because it's shaded below. Okay. And we also have the slope and the y-intercept. So that should be pretty easy. It was all given to us. Okay. The next one's also pretty easy. This line right here is shaded above. So it's going to be greater than or equal to. The y-intercept is negative 3. So we've got negative 3 down there. And we have a 1/3 slope. So up 1, 1, 2, 3. Okay? Down 1, 1, 2, 3. Okay, and we get that point there. So those two are pretty straightforward and simple. Now, for the last one, again, we have a solid line. So that helps because it's going to be or equal to. So it's shaded above. So I have greater than or equal to. My slope, if I count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, left 1. If I go left 1, that's negative 1, so this is a negative 9 slope. Okay? Now, how the heck did they get that negative 31? Well, here's how they did it. If you remember from before, we know that the inequality, you can write it as an inequality. That might confuse you a little bit. Let's write it just as y equals mx plus b. Okay, understand the inequality will still be present. Now, we know the slope is negative 9, so I'll go ahead and plug that in. We know that the point to which it goes through can be either one of these points. So if I use this point here, negative 1, 2, 3, negative 1, 2, 3, 4. So if I plug those values in, negative 4 is the y value, negative 3 is the x value. If I simplify this, this would be positive 27, If I subtract 27 from both sides, we get negative 31. That's your y-intercept. So that's how you get your y-intercept. Okay? You've got your slope. You know the inequality. It's not too bad. Now, I will tell you this. Some of these you can just count. Like number 1, if you want to just count this slope right here until it gets back to the y-intercept, you can do that. Okay? But some of them you can't count. And so like this one right here, you can count this slope until it gets back to the y-intercept there. All right? I'd like this completed for Monday. If you have questions, please talk around to somebody to make sure you got everything figured out. And I'll see you on Monday. Good night.